All right. Um, Thanks for having me. As Zach said, I am a huge fan of this technology. And I think at a personal level and a professional level, this is the right thing. The right thing at the right time is always a good thing. Um, I work at the Office of Naval Research in the battle space environments and systems department, and I head up the maritime sensing group within that department. So anything and everything having to do with sensors applicable to the maritime environment comes in my shop. Uh, so all sorts of weird, crazy ways of designing acoustic sensors, magnetic sensors, radars, lasers, you name it. I'll play with it. All right. In terms of just putting things in context, um, that small little blip on the far right is expanded into the areas that I operate. Um, as you can see, there's a lot more money um, allocated for other things. Most of that is in supporting the existing fleet. Um, and the R&D budget is a small sliver of that. But with it, we do pretty cool things with it. And I try to keep it real. Office of Naval Research directly funds or manages the 6-1 portfolio, the basic research, the applied research, and the advanced research development efforts for the Navy and the Marine Corps. We also have the capability of handling 6-4 dollars as well, but generally we have the authorities for 6-1 through 6-4 and mostly 6-3. That's important to understand in this room because it is the S&T R&D dollars. This is all of it for the entire Navy. Okay. Um, yeah, I'll leave that. Inside of that, inside the building, we have priorities, and these are those priorities as laid out. The items that are highlighted, or the one that is highlighted, is the undersea battle space uh, and marine domain. That is the group that I am part of, and inside of that, um, the boxes that are highlighted in red are those domains that I specifically focus attention on. As you can see, though, the entire department covers pretty much everything you guys are interested in, mostly interested in. And so I highly encourage you to reach out to me and the rest of the department to dig into how you can support what we're up to. And, Tim has been a catalyzer in that regard with the BristleCon technology and the whole team, the BristleCon team. For me, what's notable, I tend to manage mostly between the 6-1 and 6-3. And the way that I do this is recognizing kind of what's going on inside the bureaucratic process that is S&T in the government, and realize that what is often missing is the distinctions that can be made between developing the capacity to do something and developing a specific capability to do it. Those are different and they need to be treated as such. The capacity is the basic ability to do it, and the capability is that ability applied to a specific problem. Now, that distinction is important when you're trying to develop the technology in the first place because you don't know where it's going to land. And if you actually collapse those things, you kind of miss a whole lot of really cool opportunities for how that technology that has a certain ability could support something else. Again, something that gets in the way is if you don't have interfaces that support it going in other places than those that you originally planned, you're going to miss that as an opportunity. So one of the things that shows up here is the people who tend to focus strictly on research tend to focus particularly on research. And so research begets research begets research. And that's interesting, but it doesn't actually necessarily solve my problem. Similarly, though, um, if you don't have that, the application side of things can never discover those technologies. And so what I've tried to do in my program is create a tech base. This typically is in the 6.2 domain to try and create scenarios and opportunities for the technical ability to do something becomes discoverable by those folks that are looking for a particular capability. Okay. In the sensing domain, the way that shows up, well, basically this is a canonical sensor. I don't care what kind of sensor it is. It's going to have this kind of basic structure, and I challenge you to challenge me on that. Data's coming in. It's going to be sampled in some way, and sampled in space, sampled in time. It's got a space-time bandwidth product. That data needs to turn into information, however, at the end of the day. So we go through signal processing and communication constraints. The takeaway here is that all of these individual pieces become constraints. And the biggest one, of course, shows up down at the bottom for most problems is how do you get this deluge of data that you're collecting in this skinny little pipe that typically is available to us, all right? What isn't shown here is there's always the energy constraint, all right? We heard earlier today that pretty much anything that you have to do in the maritime environment has those two constraints. You never have enough energy, you never have enough communication bandwidth. So this is everywhere in my domain, in your domain. So what is a strategy for managing this? One of the things that I identified as a major constraint that kept showing up over and over again, it shows up in everything I do, is the interfaces. And the interfaces that particularly those that support the energy and the communication. All right. And boy, wouldn't it be nice and fabulous if someone would come up with a standardized way of managing those resources, and not only standardize them, but make them dynamically allocatable. Okay. Well, I think that's where we're headed. And I've been looking for it for 30 years. So we're sitting at a very pivotal point right now because people are pushed up against the edge with the cost of everything. We're not actually taking samples in ways that don't require crazy amounts of processing and time to extract out whatever meaning we can get out of it. It's just not a very efficient process, and it doesn't scale. And the main reason it doesn't scale is because of the interfaces. So it's kind of what I noticed was, what is it about Lego blocks that makes them so cool? It's kind of the same problem. Lego blocks have a standardized interface. That is what makes them the coolest toy I've ever seen. Okay, you can make pretty much anything out of Lego blocks. And I was just playing a game with it. And, it is a game, so you have to play with it. And what I found is, just what happens with the combinations. How many different ways can you make something, make the connections with the Lego blocks? Well, of course, if you have one block, you got one combination. But look at how the combinatorics work. Now, I'm just talking about the math now, right? The math is stupendous. It's absolutely crazy. The number of combinations of things, structures that you can make with Lego blocks just by standardizing the interface. All right. There's a takeaway here. And that takeaway is you can get a lot of leverage if you pay attention to the interface. All right. That's not what we typically do. And so I am tickled to death that we are finally getting to a point where we're actually recognizing the impact that can be made by actually doing that. I'm an information theory guy at my heart, and one of the things that comes out of thinking in that weird kind of way is you recognize that you can work really, really hard to get total accuracy out of a sensor, or you can work really, really smart and get a little bit of indicators from a lot of sensors, particularly if they're independent. It collapses the uncertainty much faster. Diversity is a really, really powerful tool when used properly, but you have to have the interfaces to support that. So that's, the plug and play type sensing capabilities that I see coming through the bristle mouth interface, coupled with the machine learning and AI stuff that's coming online. The world is getting ready to change in a really, really dramatic way, because this is not just undersea. This is going to show up everywhere for people who are actually paying attention to it. It's an opportunity for you to be on the front of it and take full advantage of it. I certainly am. The last thing I wanted to say is, like I said, this is an opportunity. And, you know, um, in my old age, I have kind of become a amateur historian, and I like thinking about things deeply. And I kind of came up with this. It says sensing agents that organize their actions to conform or fit an arena, create a sensing worldview. Continually refining that worldview reliably generates modes that are consistent with our best scientific understanding, and it yields a nomological order. Now, what I mean by that is it becomes the law. All right? You actually create your understanding, and the understanding gets created by the connections that you can make. That's where it comes from. I mean, you can think about this from a philosophical perspective as well as an engineering perspective. The two are synonymous. I actually think that weird way. It is weird. I will freely admit that. But we're in a really interesting place right now where I think we're going to surprise. We're in a position where we can really surprise the world, because we, for the first time, don't have to know a priori what's actually going to come out the other end. We can actually use the tools to help create both the performance that we want and the resilience that we want. We saw a graph earlier, I think it was you that pointed it out. It's like if you create something and you only focus on the performance aspects, you're going to make something that has a very high Q, but is super, super sensitive. All right. And any dithering, anything that you do that isn't perfectly aligned with what you expected it to be, you're going to fall off the cliff. That's the kind of point solution we don't need. because it fools us into thinking that we've solved a problem that we actually haven't. Actually taking an engineer's approach to it and realizing that you never create a control system or any system without considering both the performance and the resilience together is key. And that's what makes things make sense. So hopefully I haven't totally gone off the philosophical realm here, but to me, philosophy and engineering are connected at the hip, right? Because guess what? I'm human. So that's it. Mhm.
Did you want to take a talk? Did you want to take a talk then?
Sure.
So I think we have, we're going to try to squeeze some things together, but I think we have time for maybe one or two very quick questions, but they have to be good ones. So
Philosophical.
could be philosophical. We could get there.
Yeah.
Right.
All right.
So I have a I'll fill in philosophically speaking. Can we borrow this quote for our website?
Sure.
Awesome.
Yeah.
Thank you so
Yeah.
much.
Yeah.